Hello. All right, this is the problem I meant to do yesterday, but we had so much fun we ran out of time, right? All right, so we have 4 feet of wire used to form a square and a circle. We want to know how much wire should be used for the square and how much should be used for the circle to enclose the maximum total area. So we are maximizing area. Let's draw a picture. So we have a square, a circle, and now we're wondering, like, why would you ever want to form a square and a circle? I don't know, maybe you're really into shapes and you're making pens for like chickens or something. I'm not really sure. There's our square. Oh, that's not a triangle though. I don't know why I put a triangle. All right, circle. That's better. Okay, so we're trying to maximize the area. So the area is going to be like, let's say these sides are both x. This is our radius r. So x squared plus, and the area of the circle is pi r squared. Okay. And so then, let's see. We have 4 feet of wire used. That means the perimeters. So that means that perimeter of the square is 4x. 2 pi r is the perimeter of a circle, or the circumference of a circle. So that will equal 4. Okay, so we need to solve for one of the variables. Let's solve for x. So if we have 4x, if we subtract 2 pi r on both sides, 4 minus 2 pi r, divide by 4. X is, let's see, 4 over 4 is 1. So that's going to be 1 minus 2 over 4 is 1/2 pi r. So now I'm going to go back over here and rewrite. So instead of x, we're going to have 1 minus, I'm going to make it pi over 2 instead of 1/2 pi. So pi over 2r squared plus pi r squared. Then we will differentiate. A prime is 2 times 1 minus pi over, I'm sorry, not 1 minus, right? Actually, yes. Losing my mind, guys, as usual. 2 times 1 minus pi over 2r times the derivative of the inside, which is negative pi over 2, plus 2 pi r. So this is 2 times negative pi over 2. Those cancel, so we just have a negative pi times 1, which is negative pi. That's not a line. Negative pi. And then negative pi times negative pi over 2 is going to be a positive pi squared over 2 times r plus 2 pi r. We can take out a pi. Then we have negative 1 plus pi over 2r plus 2r equals 0. Okay. We can divide both sides by pi because we're solving, so the pi can just go away. So we can set negative 1 plus pi over 2r plus 2r equal to 0. We're getting there. Add 1 to both sides. We end up with, let's see, pi over 2r plus 2r equals 1. If I factor out an r, I end up with pi over 2 plus 2 equals 1. So r is 1 over pi over 2 plus 2. What a lovely critical point that is. Okay, so let's take the second derivative. Switch colors, it seems about time for that. Second derivative, again, our original function was that, or rather our first derivative was that. So we take the derivative, we end up with pi squared over 2, because this goes to 0. Pi squared over 2 times r, this is just a constant, so we have pi squared over 2. This is also just a constant, plus 2 pi. This is some positive value, so this must be a minimum. And then we're like, wait, what were we trying to find? Shoot, we were trying to find the maximum total area. So what's the answer? Endpoints. So for the endpoints, basically you can either use all wire for the square or all wire for the circle. So if R equals 0, all wire is used for the square. And the square again looks like this. And so if you get to use, again, our total was 4. We had 4 feet of wire. So if we use 4 feet of wire, that means X has to be 1, right? And so then the total area is just going to be 1 times 1, which is 1, was it feet that we had? Yeah, it was 1 square foot. Okay, now let's check the other endpoint. What if we use everything for the circle? So if X equals 0, all wire is used for the circle. So then our circle is like this. So what that means is that the circumference 2 pi r is going to be equal to 4. So that means the radius would be 4 over 2 pi. You still with me? I have to assume yes. Okay, so if r is 4 over 2 pi, then the area of the circle is going to be pi r squared, or pi, times 4 over 2 pi squared. And this ends up being, honestly, just use your calculator, or either leave it like that or use your calculator. But it ends up being 1.275 square feet. And so, okay, we had 3 options here. We had our critical point, that was a minimum, no good. We have 1, and we have 1.275. Well, what's bigger? 1.275. What does that mean? Well, it means the maximum area is enclosed when all 4 feet of wire is used for the circle. And one more time, I'm just going to check and make sure I answered the question. How much wire should be used for the square and how much should be used for the circle to enclose the maximum total area? So I answered it. All 4 used for the circle.